I am Dr. Chalpati Rao. Today we are focusing on Tautomers and Tautomerism. The purpose of this topic is to answer questions such as which compounds are having tautomers and which compounds exhibit tautomerism. Then what are tautomers? Tautomers are the isomers. Then what are isomers? Compounds having the same molecular formula but differ in their properties are called isomers. There are so many varieties of isomers. There are so many types of isomers. Chain isomers are there, position isomers are there. There are various types of isomers. Among those, one of those isomers is tautomers. Then what are tautomers? The isomers which are formed by migration of proton are called tautomers. All compounds does not exhibit tautomerism and does not have tautomers. Those compounds with polar groups such as C double bond O, NO2 and nitrile groups with alpha hydrogens exhibit tautomerism and have tautomers. As carbonyl group is present in carbonyl compounds with alpha hydrogens exhibit tautomerism. As nitro group is present in nitroalkanes with alpha hydrogen exhibit tautomerism. So, as nitrile group is polar group, cyanide compounds with alpha hydrogens exhibit tautomerism. For example, this is acetoester ester. CH3, C double bond O, CH2, C double bond O, C2H5. This is acetoester ester. So it is having polar group and an alpha hydrogen. As it is having polar group as well as alpha hydrogen, it has got tautomers. So this is acetoster ester. It exists in two forms. This is one form. This form is called keto form. And this is another form. So this is another form. As these two forms are formed by migration of proton, these two are called tautomers. This form is called keto form and this form is called enol form. Acetoster ester exists in 92.5% in keto form and 7.5% enol form. As acetoster ester have polar group as well as alpha hydrogen, it exists. So it exhibits tautomerism and exists in tautomer forms. This is acetyl acetone. CH3, C double bond O, CH2, C double bond O, CH3. It exists in two forms. So this is one form. This form is called keto form. And this is another form. This another form is formed by migration of proton from this carbon to this polar group. This form is called enol form. This form is called enol form. As acetyl acetone have polar group as well as alpha hydrogen, so it exhibits tautomerism and exists in two forms, in tautomeric forms. One form is called keto form, another form is enol form. This acetyl acetone exists to 20% in keto form and 80% enolic form. I'd like to mention one point, that is, all compounds does not have tautomers and does not exhibit tautomerism. Those compounds which have polar group as well as alpha hydrogens are only exhibit tautomerism, or only have tautomers. For example, this is 1,3-cyclopentane dione. It has tautomers because it has polar group as well as alpha hydrogens. Similarly, this is cyclohexane 1,3-dione. It has polar group as well as alpha hydrogens. So it have tautomers. But this is formaldehyde. It does not have tautomers. Though it has polar group, it does not have alpha hydrogen. That is why it does not have tautomers, it does not exhibit tautomers. Similarly, this is benzophenone. This is benzophenone. So it also does not exhibit tautomers. Though it is having polar group, as it does not have alpha hydrogens, it does not exhibit tautomerism and does not have tautomers. Therefore, the necessary condition for the exhibition of tautomerism is presence of polar group with an alpha hydrogen.